So we've got this Excel file, right? And so for the poster, there's a lot of ways you can skin this cat. A lot of ways you can explain the results. One of them would be to I'll show you some ways I've done it in the past. So this is a relevant one because this is a center surround paper that I did with Yu-Chen on schizophrenia. And see, it was the dots and which way do the dots go when they have a surround. And this is the way we drew it in that paper. And I think for that paper, this is a good way to do it. We drew the controls. We drew their baseline, proportion of time they reported the trial rightward, when there was 100% coherent moving dots leftward, 40% moving to the left, 20% moving to the left, 0, which is totally noise, and then all the way to 100% moving to the right. So we graphed all that for the baseline condition, which is no surround. And then on the same graph we have when there's a leftward surround and when there's a rightward surround. And you can see the punchline is, the leftward surround makes you say the center is rightward more frequently. See, the black is generally above the white stuff. And the gray is kind of generally below. It's not actually perfect, but that's basically what it is for the controls. But it's kind of like a small effect. You don't see it on... like the gray is on top of the white on this side, and the black is sort of on top of the white on this side, so it's not like the strongest effect in the world, but there's this little effect of center surround stuff. But then if you look at the schizophrenia patients, it's a massive effect. And you can see, that their baseline is in the middle, but there's this huge amount of space between the black and the gray as compared to that. And I think this is a nice way to draw it. So all three conditions for each subject group kind of drawn separately is what's going on here. And then there's this other graph here, which is where you sort of do subtraction between the baseline and like the other conditions, whether it's the same direction or the opposite direction as the center. And those difference scores are graphed here, and patients and controls are on the same graph. Okay? Okay. So this is for, incongruent, and this is for congruent. So this would be like, so for us, we could do this exact same layout where we have ISO, cross, and baseline for controls, ISO, cross, and baseline for depressed. And then even a third graph if you want, ISO, cross, and baseline for recovered depressed. And so from that we would have 3 graphs, just like these. And then we could also do ISO minus baseline shift, like percentage shift. And then cross minus baseline percentage shift. And we'd have 3 lines on each graph instead of 2, because we have a recovered depressed group in addition to the depressed group and the control group. I don't know. There's other ways to do it, but to me this seems satisfactory, and I don't know that it would be worth it to exhaust all possible ways we could do it, since this seems like a pretty good one. But I wonder if you guys do have improvements upon that. I like this graph, this adding of basically showing you what this graph shows with the arrows, you guys could do that same thing with like showing a cross minus a baseline Klein stimulus without a surround, and then an ISO minus a, see if you can slap that on the actual figure to help people know what they're looking at or understand quickly what they're looking at. But yeah, what do you think? That sounds okay? Okay, cool. So let's look at this real quick and see if we can figure out how to graph these in MATLAB. All right, so sometimes in MATLAB it's helpful to, so what we're going to do is something like this. So I'm going to grab, let's see, let's find the baseline. It's always good to start with the baseline, right? Baseline. And I think the second group is the control group. Let's just double check I'm selecting the right people. Yeah, this white group. Yeah, good. That's the controls. So I'm going to grab just this little set of summary data that I've put at the bottom. So, and I'll write this out for you. So this is normal control. This is current MBD, and this is recovered. All right. So what we'll do is grab just the controls right now. So I'm going to say control data equals, and then I'm going to put little bracket thingies, and in the bracket thingies, I'm going to paste the thing I just grabbed. And then MATLAB is like, okay, thanks. So I hit CLC to get rid of all the gunk that was just there. And now if I type control data, look at that. It's this little matrix, just like from Excel. And what I'm going to do is say, I'd like to graph, if you don't mind, these data. So I will say plot. This is the command we use in MATLAB to graph things. And well, first I'll say figure. And then this little thing appears, and on this little window will come the plot. So now I'll say plot, and I'm going to tell it what to use for X data. And actually, look at this. All this stuff, the suggested syntax basically comes up for you and tells you, like, this is how you are going to go about this. So it's going to look for X data and Y data. X data, comma, Y data. Then you close your parentheses, and you'll be good to go. So the X data, we actually don't have the X data, right? In our little data that we just entered. So what I'll do is enter it now. So I'll make brackets and I'll say, what are our X values? Does anyone have those handy? Like the contrast values that we use that we're going to put on the X-axis for the graph? If it'll take a little while, we can just, for now, we'll just put 1, 2, 3, 4, 5, 6, comma, and then the Y data. So the Y data, see, it says, the Y data, I believe, are the top row of that matrix right there. So 0.029, et cetera, 0.1694. And so what I could do is this, 0.024 space 0.1694. But if we had to do this, we're going to do a lot of graphs, so that would be onerous. So what we'll do is we'll say control data, and you can in MATLAB you can refer to a part of that variable. Control data is that whole matrix with those 4 rows to it. So what we're going to do is just refer to the first row, which is row number 1, comma, and so we're going to tell it which rows we want and which columns we want out of this variable. And so we want the first row, and we want all columns, and you denote all columns with a colon. And then, so we close that little parentheses of which part of control data we want. And then we're going to close the plot command parentheses. Then we're going to hit enter. And look at that. We have our little graph. It's so pretty. It's actually not that pretty. It's pretty bare bones. Let's make it a little bit better. Let's try it again. And so a little trick, I just hit up, and that repeats the command that you did last. So what I'm going to do is go before the last close parentheses. You can specify little stylistic stuff if you hit a comma. And so you do a comma, and then you're going to put it in apostrophes, and you're going to say like these little codes for like stylistic stuff. So I'm going to say we want a line graph. So I put a hyphen to denote that. I'm going to put a little 0, which means I want at every point, I want it to have its own little dot, not just like a line, but like dots connected by a line. And let's make it, whatever color you want. We could make it cyan, I believe is C. So there you go. Cyan is not a good choice. Let's try that again. How about black? Okay. Ah. Oh. I think I killed our graph. Sorry. Try that again. There it is. Okay, cool. So that's starting to look pretty decent. But there's really no reason to make a graph if you're not going to put error bars on it. Unless you really just want to deceive people, that's really the only time you would ever make a graph without error bars. And people do that all the time. They want to make their data look cooler than it is, so they draw it without error bars. But if you want to actually give people a sense of the truth of like whether they can trust your data, you need to put error bars on that. Bad Larry. So let's do that. So to do that, we are actually going to use a different command instead of plot. We're going to do pretty much the same thing, but instead of plot, we're going to say error bar. I think that's what it is. Is that what we're going to do? Yeah, sure. And I believe, let's see. So in MATLAB, good thing to know is if you know what you're doing, you can type help error bar, and it will give you all this spiel of like what the syntax is supposed to be like for that command. So yeah, look at that. Error bar. Yeah, there's multiple ways you can do it. You can just type the Y data and then the data for your error bars, how big the error bars are going to be. Or you can do X data and then Y data and then how big your error bars are going to be. So that's what we're going to do. So let's try that. Error bar. So let's see. Well, let's use what we had before. So I'm going to use. So instead of plot, we're going to say error bar. And we're going to use this for X data. We're going to use that for Y data. Now we just need to add another one that's our error bar data. And so it's going to be control data. Which row do you think it is? I forget. My guess would be you guys probably forget too. Unless you have photographic memories, which I don't think exists. So control data. I used to know a guy who was pretty famous because he supposedly discovered a woman with a photographic memory at Harvard, and he like proved it beyond a shadow of a doubt, like this crazy experiment he did with this woman. But then he married that woman, and she refused to ever be tested again. So it was like a big like, people think he made it up. Interesting guy. So I think the error bar stuff we want could be here. No, it's the last row. This is the standard deviation. This is the n, and this is the error bar, the standard error, which is what we're going to use for error bar. So it's the fourth row. So let's try it again. Plot, comma, control data for, okay, and then instead of plot, we actually meant to say error bar. How's that for nice? Very nice. All right. So now we're cooking with gas. So what I'm going to do is put this into a little script command I just used that you guys now are intimately familiar with. I'm going to put in this little script so you can remember. And what you can do is just press play, and it will do all the things that we just did one by one in the little, this is called the command prompt. So we did figure, we said control data equals whatever we said it was. And then I'll do a little semicolon after that just so it doesn't, it'll be better to do that. figure control data equals, and then we just said error bar. I'm just going to copy this. Look at that. All right, so now watch this. So I'm going to do clear. And now, so like, it's as if I didn't even set the control data variable anymore. I don't know if, yeah, you probably didn't see because the zoom thing was over, but before, so if I say A equals, 42, see it comes up here, there's this little variable A, and the value is 43. The control data thing was there before, but if I type clear, that kills all the variables I have. So right now we have nothing, but the good news is if I hit play, it's going to ask me to save it. Klein graphs. Save. Oh, I'm sorry. Klein underscore graphs. I think it doesn't like spaces in the name of a file. So see, if I, let's do it again now that I saved it. That was kind of distracting. So now if I hit play, waka waka, we get our graph. It's very nice. So now what you guys can do, this is actually getting pretty powerful. What you can do is copy, you can have remitted data and paste that in. And then you can just copy this command here and have it refer to whatever you call your remitted data variable. And you can change the color of that. Let's just do that real quick so you guys can see one more. I'm going to also control baseline. Okay. It's nice in MATLAB to create, these are called cells, just to kind of like little different sections of your code so you don't get as confused. So now we'll say current MDD baseline. All right. And I'm going to do the same thing. Where's our thing here? Grab these guys, Control C. And we're going to say, what do you think? MDD, or current data, I think we should have called it baseline, to be honest with you, equals that thing I just grabbed. All right. Oh, sorry, I should have said it here. Current data. Well, we don't need the word data there, really. Just say current baseline equals that. Good. Good. Okay, and then we say, I'm going to use a command called hold on. What this means is that, well, actually, I'll show you what it means. I'll start without using that command, and you'll see what happens. So what we're going to do now is just grab error bar command, copy it, and instead of control data 1 or whatever, we're going to say, what are we going to say? Somebody tell me.
Current baseline.
Current baseline, exactly. Suggestions for a color instead of black for the currently depressed people?
We forgot the underscore for the.
Good. How about blue because they have the blues? And let's instead of control data, we'll say control baseline. And then I'll have to fix this. Yeah, control baseline. Okay. I don't know. Let's see if it works. Look at that. Now, why aren't there two lines on this graph? I ran my program, and this one draws a nice black line for the controls. This one draws a nice black line for the blue line for the patients, but all I see is a blue line. The reason is I did not enter the hold on command. If you don't enter that, it just erases whatever was there before and draws a new graph. So let's try it if I do hold on. And again, type clear. Nice. I'm a little bit disturbed by the fact that there's no like room on the end of the axes. I'd like a little space, like you know, uh, so that it's not like right on this line here at the end. So let's mess around with the axis. So you do that by using the axis command, and then I think you do X and then Y. Like the X starts from whatever to whatever. Let's do 0 to 7, and Y is going to be, I think, from 0 to 1.04 or something like that. Let's try. Yeah, that's nice. And give a little room at the top just in case there's a 1. It won't be right on the top. That's why to 1.04. Okay, that's nice. So, does this make sense? Okay. Uh, from this, if I send you the Excel spreadsheet and I send you this little Klein graphs program that we've just created, are you going to be able to make all the graphs that we talked about at the beginning of this video / meeting from the Yu-Chen paper? I can send you that paper too. Remember these graphs. Jaslyn, are you trying to speak?
Sorry, I didn't unmute myself. I think we could definitely make the graphs that were like comparing the baseline, the ISO, and the cross with the like current depressed patients, the recovered depressed, and like the controls.
Yes.
But I don't know if I'm gonna know how to do like the ISO minus baseline and like cross minus baseline
Yes.
ones.
How would you do that?
I don't know. That's what I'm asking.
Well, I think um, I think actually maybe it's already in the thing here, in the spreadsheet. So see baseline. You got to kind of go over for a while. DD, whatever, even all these things. G. See, look at this. Klein ISO minus space. Right here. Let's just make sure it's referring to the correct thing. CF minus BW. Yeah, baseline. CF. Yeah, good. So that thing at the end here is what you're going to use. Right here in column F0 through FT. And then from FV to FZ. But you're going to go to the, so first of all, you're going to have to put periods. All the people that we're missing over there and that have periods, you're going to have to put periods in for them too on these different scores, just so you don't get like an error. But actually, it's already calculated for you. The same scores for the current control and remitted are right here. And I'll just delete this one so you don't get confused. Okay. So you have that for cross and ISO. Way over in the F columns. So you just grab these babies for those. Does that make sense? Okay.
So we're just doing those 5 graphs. Were there any others that you mentioned?
I think that's a good place to start. If you guys can have those done by lab meeting, that'd be good.
Okay, and then my last question is how do we figure out the X data? I think you'd mentioned we had to find that.
Jinyoung, can you try and look that up somewhere? Okay. If you can't find it, we can look for it during lab meeting. It's somewhere in a code somewhere or something like that, I think. Yeah. Okay. Cool. So just for my own benefit, I will repeat the things I think I'm supposed to email you right now. So I'm going to email you the Yu-Chen paper with the graphs that you're going to model. I'm going to email you code that we just created, and I'm going to email you this updated version of the spreadsheet.
Sorry, this is the about the x-axis. It's the contrast levels, right? The
Yeah.
6. So I have them if you
Okay,
want me
cool.
to
Let's
put it.
just, I'll put them in these guys right now, and you can just use them again. So instead of here, yeah, right. What do you got?
0.22124, 0.29498,
Oh, sorry, hold on. Let's just go 3 decimal places for my own.
so second one 0.295,
Okay.
and then 0.332, and then 0.405. Or I guess you could round it, but 0.442, and then 0.516.
Cool. Yeah, great. And do you have the comparison level there? Is it 0.38 or something?
Sorry, what do you mean by
So these are the contrast values for the test stimulus, which I believe is the stimulus that doesn't have a surround, the one that's off by itself. But the one that's in the surround is always the same value. And I think that value is like 0.38 or 36 or something. It's okay if you don't have it. It should be whatever the mean of these two is, 0.33 and 0.405. Yeah, 368, I think is what it is. Okay. That may or may not be useful for you to like put on your graph or something. Okay, cool. So I'll email you those things and let me know if you have questions. I'll also post this video to YouTube if you need to reference it. Cool. All right. Thanks a lot.
Thank you.
Thank you.